The graph shows the attendance at a sports game as a function of time in minutes. So remember our key words. As a function of, we can see that time is our input, and we can see attendance is our output. Number one, describe how attendance changed over time. Well, if we look at the graph, we see this steep line, this very vertical line to start with. This indicates a rapid change or a fast change. So it looks like attendance increased quickly for 10 seconds. So we'll say it increased quickly for 10 seconds. Then we see this little line segment where it starts to get flatter. So we say that it increases slowly for about another 5 seconds. Next, we see this long line segment that's completely flat. That means the attendance stayed the same. And that happens from 15 seconds until 45 seconds. So we'll say that it stayed the same for 30 seconds. Then we see this decline, and this decline is fairly steep. So we'll say it decreased quickly for, it looks, about 5 seconds. Then we see this little line segment where it's flat again. So that means it stayed the same for about 5 seconds. And then at the end, we see it decline steeply again. So we'll say it decreased quickly, and it looks like it took about 15 minutes. So we need to make sure that we pay attention not only to what our input is representing, but what unit it is representing it in. This is minutes, not seconds. Number two, describe the domain. A domain refers to all the possible numbers that you could use for your input. Our input is talking about time in minutes. And if we look at our graph, we see that it starts at 0. There's a solid line So it does include partial or fractional minutes, and it ends at 70 minutes. So the domain would be all real positive numbers between 0 and 70. Number 3, describe the range. The range refers to all possible values of your output numbers. And if we look, our y value starts and ends at 0, and at the highest point on the graph, it appears to be about 55. And since we have a solid line, it is also including every number in between. So if we look at this attendance wise, we cannot have partial people, but these numbers 20, 40, 60, if we think about a sporting event, these numbers would most likely represent thousands of people. So the partial numbers here would be partial thousands, not partial people. So we would say all real positive numbers between 0 and 55. Toronto is a city at the border of the United States and Canada, just north of Buffalo, New York. Here are 12 guesses of the average temperature of Toronto in degrees Celsius in February 2017. Number 1. The actual average temperature of Toronto in February 2017 is 0 degrees Celsius. Use this information to sketch a scatter plot representing the guesses and the corresponding absolute guessing errors. So we can see that the x-axis represents the guess and the y-axis represents the absolute guessing error, or how far away that guess was from the actual number. When we want absolute guessing error, we do not care about the sign. We only care the distance from the actual number. So our y values will always be positive. So we have a guess of 5. That means we go over to 5, and that guess is 5 away from 0. So we put our first point. Then we have a guess of 2, so we go over to 2, and that is 2 away from 0. So we plot our second point. Then we have -5, and -5 is 5 away from 0. 3 is 3 away from 0. 0 is the correct guess, so that point is at the origin. -1 is 1 away from 0. 1.5 is 1.5 away from 0. 4 is 4 away from 0. -2.5 is 2.5 away from 0. 6 is 6 away from 0. 4 again is 4 away from 0. And -0.5 is 0.5 away from 0. So when we plot these points, this would be the scatter plot representing the guesses and the corresponding absolute guessing errors. Number 2, what rule can you find, or what rule can you write to find the output given the input? So this V shape is the generic graph of y equals the absolute value of x. Because all we did was take the guess number and make it positive. So all of the positive guesses stayed positive. So you can see all of our points, such as 2 are 2, 4 is 4, 6 is 6. And then we took all of our negative guesses and just made them positive. So -1 becomes 1, -5 becomes 5, and so on. So the actual rule we would use is that y equals the absolute value of x. Here is the graph of a function. Select the equation for the function represented by the graph. So if we look at these, A has a -5 outside the absolute value symbols. So this represents a shift down 5 units. B has a +5 outside the absolute value function. So this represents a shift up 5 units. C has a -5 inside the absolute value function. So this represents a shift right 5 units. And D has a +5 inside the absolute value symbols. So this represents a shift left 5 units. The generic function puts the vertex at the origin, making a V shape. So this was shifted down 5 units. So that means choice A is the correct match. Each equation represents a function. For each, find the inverse function. So for number 1, if I have c equals w plus 3, the inverse function will be w equals. So I need to get rid of this 3. The opposite of plus 3 is minus 3, but if I subtract 3 from the right, I must subtract 3 from the left. This gives me an equation that says w equals c minus 3. Now I have the inverse function. Instead of solving for c using w as an input, we now solve for w using c as an input. Number 2, we have y equals x minus 2. The opposite of minus 2 is plus 2, and if I add 2 to the right, I must add 2 to the left. Now I get an equation that says x equals y plus 2. Now, instead of an equation that solves for y using x as the input, we have an equation that solves for x using y as the input. Number 3, y equals 5x. 5x is multiplication. The opposite of 5x is dividing by 5. If I divide the right by 5, I must divide the left by 5. Now I have an equation that says x equals y divided by 5. Now, instead of an equation that solves for y using x as the input, I have an equation for x that uses y as the input. And number 4, we have w equals d divided by 7. The opposite of division is multiplication. So if I multiply the right by 7, I must multiply the left by 7. Now I have an equation that says d equals 7w. Instead of an equation that solves for w using d as an input, I now have an equation that solves for d using w as an input. This is how you write inverse functions. Function C represents the dollar cost of renting a bike from a bike sharing service for t minutes. Here are the rules describing the function. Number 1, complete the table with the costs for the given length of rental. Sketch a graph of the function for all values of t that are at least 0 minutes and at most 240 minutes. So if we look, our first time is 0 minutes. In this first value, 0 is not included. So there is no cost for 0. Obviously, if you don't rent, then there is no cost. So we could put our point at the origin. Then we have 10 minutes. 10 minutes is between 0 and 30, so the cost would be $2.50. Our next time is 25 minutes. 25 is between 0 and 30, so it would also be $2.50. If we wanted to graph this, notice we have 0 is less than, so we could go to $2.50 and we would draw an empty point because it is not included there. Then it's less than or equal to 30, so 30 is included. We would put a solid point at $2.50 and draw the line connecting them. Our next time is 60 minutes. This is going to follow the second rule because we have less than or equal to 60. So that cost would be $5. When we draw that part, we can see that 30 is not included because it is only less than. So we're going to put an empty point, but then it's less than or equal to 60, so 60 is included at that cost. And we draw the line connecting. Our next time is 75 minutes. That is between 60 and 90, so the cost would be $7.50. When we draw that step, it's less than 60, so it's not included. We draw an empty point. Then it's less than or equal to 90, so that point is included. We draw a solid point, and then we draw the line connecting them. Our next rule is less than 90, or 90 is less than t, so it is not included. And t is less than or equal to 120, so it is included. We draw a solid point and the line connecting them. Our next time in the table is 130 minutes. That is between 120 and 150, so the cost would be $12.50. On this one, 120 is only less than t, so it is not included. So we have an empty point. And then t is less than or equal to 150, so that point is included. And we draw the line connecting. Our final time is 180 minutes. That is between 150 and 720, so the cost would be $15. When we draw that step, we see that 150 is only less than t, so it is not included. We draw an empty point all the way up to t being less than or equal to 720, So on this one, we're stopping at 240, so we'll put a solid point because it is included, and then we will draw the line connecting them. This is how you can fill out a table with the y values using the piecewise function when you're given the x values. And then this is also how you can draw this piecewise step function. You use an empty point when that value is not included. You use a solid point when that value is included. Tickets to a family concert cost $10 for adults and $3 for children. The concert organizers collected a total of $900 from ticket sales. In this situation, what is the meaning of each variable in the equation 10a plus 3c equals 900? We can see that the a is attached to the 10. And in the description, the $10 is associated with adults. So for number one, A equals number of adults. Then we have 3C, and we can see that $3 refers to children. So C equals the number of children. Number two, if 42 adults were at the concert, how many children attended? If we know we have 42 adults, then we have 10 times 42 plus 3c equals 900. We multiply 10 times 42 and we get 420. Now we subtract 420 from each side and we get 3c equals 480. And lastly, we divide both sides by 3 and we get c equals 160 children. Number 3. If 140 children were at the concert, how many adults attended? So this time we substitute 140 in for C. We go ahead and multiply. 3 times 140 equals 420. Again, we're going to subtract 420 from both sides. 900 minus 420 is 480. And now we're going to divide both sides by 10. And A equals 48 adults. Number 4. Write an equation to represent c as a function of a. Explain what this function tells us about the situation. So if we have 10a plus 3c equals 900, and we want the equation to represent c, we'll subtract 10a from both sides. This gives us 3c equals 900 minus 10a, and then we will divide both sides by 3. And this gives us c equals 900 minus 10a divided by 3. And this function tells us the number of children using number of adults as input. And number 5, write an equation to represent a as a function of c. Explain what this function tells us about the situation. So again, we start with 10a plus 3c equals 900. We want the equation to say a equals this time, so we're going to subtract 3c from both sides. We get 10a equals 900 minus 3c. Now we're going to divide both sides by 10, and we get a equals 900 minus 3c divided by 10. This tells us number of adults using number of children as input. So these are inverse functions. Number 4 tells us the number of children using the number of adults as the input. Number 5 tells us the number of adults using the number of children as the input. A taxi company charges its fares based on the following rule. If the ride is less than 3 minutes, the cost is a flat $5. If the ride is 3 miles or more, the cost is $5 plus $2 per mile for every mile over 3. Represent the taxi company's fare system as a function using f of x to represent the cost of a ride x miles long. Is this function a piecewise function? Explain your reasoning. So when we label, our input is going to be miles, and our output is going to be the cost. So when we label, we can start at 0, and our miles can be whole numbers. And then our cost can do the same thing. So when we're plotting this, the first rule is if the ride is less than 3 miles, the cost is a flat $5. So we would say f of x is 5 if 0 less than or equal to x less than 3. So we're going to put a solid point. Well, we should actually just put less than for 0, because technically if you don't have any distance, then you didn't really have a car ride. So we're going to put a hollow point at 0, 5. No distance is no charge. Then we have less than 3. So at 3, we are also going to have an empty point. And we'll draw the line in between. So any distance that is greater than no miles but is less than 3 miles will cost $5. Then it tells us the cost is 5 plus $2 per mile when it is 3 less than or equal to x. So now these values, if this were a 3-mile trip, it would cost 3 times 2 is 6. 6 plus 5 is 11. So we could put a point right there. Then, if this were a 4-mile trip, 2 times 4 is 8. 8 plus 5 is 13. So at 4 miles, we would have a $13 trip. And so on. It is unclear if they are doing this rate in a step pattern or as a continuous pattern. So the wording is not truly clear on how much a 3.5-mile trip would be. But I'm going to go ahead and draw this as a step function. So I'm going to put hollow points with the lines connecting them. So this would say anywhere between more than 0 miles to anywhere less than 3 miles would be $5. Then from 3 miles to anywhere less than 4 miles would be $11. Then anywhere from 4 miles to less than 5 miles would be 13, and you would continue this pattern on. This is a piecewise function. because it follows a different rule depending on the value of x. Now they want us to describe the domain and range as completely as possible. So the wording is a little bit tricky because this says if it's less than 3 miles, and then if it's 3 miles or more, the charge is per mile. But generally, you can have partial miles. So I would describe the domain is all real positive numbers. If you described it as real positive whole numbers because of the wording, I would not count that wrong on a test. Then they want us to describe the range. Well, the range refers to the possible output values. And here we have a step function. So the range is 5, 11, 13, and every real odd number afterwards. Because it's charging $2 per mile, this pattern would continue. So next we would have a step at 15, then 17, then 19, and so on. We would never have a value at 8 or 12 or 14, anything like that. So these are the practice problems for the test. The test is Monday. If you have any questions between then and now, please let me know and use class time to get clarification.